Let's talk about including your database in a continuous integration process. If you're an application developer, hopefully you already understand what continuous integration is. You should. If you don't, then you should watch one of our other courses on continuous integration because it's a very, very important process of software development. This alone has dramatically improved the quality and pace at which we can release software. Continuous integration builds on the idea of trying to get feedback very, very quickly if something goes wrong in our code. A long time ago, when we started developing software, many people would work together. They'd work in an office for months or weeks, and they'd then try to put their code together, and it never worked. We've proven this for decades that not compiling the code until we think we're done always results in failure. Over time, we learned to do a better job. Some companies, such as Microsoft, implemented daily builds back in the 80s and 90s, and where they built the software every single day. And if it was broken, nobody could go home until it was fixed. Now, that was good because we could only cause so much trouble and so much damage inside of one day. As hardware has gotten more powerful, processors gotten faster, we've come to this idea of why should we wait till the end of the day? Let's compile our code every time somebody makes a change. So each time we commit code to a version control system, we build the software and compile it, we run automated tests, we package it for potential deployment, and we give feedback to our developers. And that's really what we want to do. We can do that with database code as well. For example, when we look at this slide, I've got a developer here on the left, and I've got a version control system represented by the diamond Git symbol. And then I've got a circular process going on. And what we want to do is when the developer commits code to the version control system, we want to start a build. And a build is a compile. In C# or Java, we compile the code. In the database world, we compile it as well, but we have to compile it on a database instance. So a SQL Server, MySQL, Postgres, Oracle, whatever system you have, we have to compile that code. We want to then run automated tests. We want to check our code, and we want to do it in a way that's consistent. I don't want to depend on those developers to run those tests every time they commit code, or that they run every single test they should. I'm going to have the system do this for me. Then what we want to do is we typically want to sync that code, if it's passed the test, into some integration spot. This allows all the code from all the developers to be put together in a place where we can examine it. We can run the application against it. We can see all the changes in one concise area. Now this is optional, of course, because if we haven't passed the test or we can't compile the code, we don't want to do this. But this does ensure that we have a working integration database. We also optionally want to publish out a database upgrade package. Now again, we have to pass the build, the test, and the sync, but we publish this package out in some format, and we store it in a repository so we have all the potential packages out there. We won't release all of them to other environments, but every one is available. And then of course, whether there are issues or not, we may want to provide feedback to our developers. Did the code work well? Did it run faster or slower? Are there any potential warnings? Anything we want, we can let the developers know. This continuous integration cycle, if we can run it on every commit, allows us to feedback information to developers earlier. That's part of the second way, providing feedback and adjusting those feedback loops, amplifying those feedback loops as far left as possible, as early in the process as we can do them. Once we do this, it dramatically starts to improve the quality of our database code.